Okay, 2014 relative velocity part B. At noon, ship B is 300 kilometers south of ship A. Okay, so A is above, B is below, 300 kilometers. Ship A is traveling southwest, so southwest is a 45-degree angle, as you all know, at 24 root 2 kilometers an hour. So we'll be able to, well, let's write down the velocities of A. Velocity of A, 24 root 2 by, in my I direction, I'm opposite, I'll do my I here. B is traveling due west anyway along this line, so my I direction is opposite, so sine, actually it doesn't matter because we know it's 45, they're both the same, but sine 45 times I. And what are my signs here? Negative actually, so I should have had a little negative in here. Just let me rub out the equal sign and change it to a negative. Minus 24, let me go back and actually put 24 instead of 2. Minus 24 root 2 sine 45 times I minus 24 root 2 cos is adjacent on the j, cos 45 times j. Now we know that sine and cos of 45 are 1 over root 2, so we're just going to get minus 24 I minus 24 j. That's the velocity of A. B, okay, B is traveling on what speed? 31 kilometers an hour in this direction. So the velocity of B is down here. Velocity of A is along this line. And the velocity of B relative to A is going to be somewhere along here. Mark that, the velocity of B relative to A. Okay, velocity of B is equal to, we've only got an I direction and we're going left, so we're going west, so we're going negative minus 31 I plus 0 j. And the velocity of B relative to A is velocity of B minus the velocity of A, or vector B minus vector A. What have we got here? We've minus 31 minus 24 minus 55. No, minus 50 minus 31 minus 24 minus 31 minus 24 I, and then minus 24 j. So that's going to give me minus 7I minus 24j. So in fact, it's down this way. Down that way, minus, we become minus plus here. No, I've made a mistake, haven't I? Because it should be in the upper direction. It's minus 24, so plus 24. Okay. So what we asked, we're asked for the magnitude and direction of the velocity of B relative to A. Okay, the magnitude is equal to the square root of 7 squared plus 24 squared. And that works out to be, that's an even one, isn't it? 7, 24, 25 kilometers an hour. And the tan of the angle, the inverse tan for the direction of 24 over 7 will give me an angle of 73.7 degrees. Now, what are we? Minus, plus, so we're going in a northwest direction. Northwest. Okay, so the second part of this question, let's draw a diagram. We have A and B can exchange signals when they're within d kilometers of each other. If the ships can exchange signals for 2.8 hours, find the value of D. Okay, so we had A, we had B. B was going in this direction, but the velocity of B relative to A was going in this direction. So there's the closest point we call X. We got this angle, 73.7. we know this is 300 from the earlier part of the question. So actually, if we can get this angle in here, 90 minus 73.7 is 16.3. That would help me get the closest distance. Then we know that these two, here and here, are going to be the same for 1.4 hours each. So we can get this. We have the speed, so we can get the distance traveled in 1.4 hours, and that should help us find the value of D. These two added together will be D. Okay, let's have a look here. We have, let me take that right angle triangle just outside. My 300, my right angle. And I've got a 16.3 in here. And I'm looking for this side here. Just look, my 300 in the wrong place, opposite the right angle is 300. And I'm looking for X. So what have I got? O and H, the sine of 16.3 is X over 300. So 300 sine 16.3 will give me X, and if we type that into a calculator, we're going to get X is equal to 84.2 kilometers. Okay, that's X, that's the closest distance. So what else can I get? I can definitely then, if I have my X and I'm looking for this bottom part, well, I have the speed that he's traveling at. He's traveling at 25, relative speed, 25 kilometers an hour. And if he travels that, these are going to be 1.4 each. So how far is he going to travel in 1.4 hours? 10%, 1.4 by 25, well, that will work out to be 35 kilometers. So now we are looking for when they can exchange signals within D kilometers. So we're actually looking for this one, not the bottom two, because we have the bottom one now is 35. We're looking for this line here. So again, just let me create a little right angle triangle. We have this one is what we've got up here, 84.2. The bottom one is 35. So this is D. So the square root of 84.2 squared plus 35 squared. If we type that into a calculator, we're going to get 91 kilometers. So that's 2014 relative velocity.